This is GATE 2016 set 2 electrical question number 47. A DC-DC boost converter as shown in figure below is used to boost 360 volt to 400 volt at a power of 4 kilowatt. All devices are ideal. Consider continuous inductor current, the RMS current of the solid state switch. This one is being asked. For NPTEL reference, you can refer to lecture buck boost and buck boost converters of the NPTEL course Power Electronic Design and Simulation of DC-DC Converters using Open Source Tools by Professor L. Umanand, Department of EECS, IISc, Bangalore. Now, if this is the structure of a boost converter, the input power is equal to the output power considering ideal condition, and the relation of the output voltage in terms of input voltage is given by V in by 1 minus delta, where delta is T on by time period, where time period is 1 by switching frequency. This is the input current I input, this is the output current I output, and this is the inductor L. The current through the inductor is IL, the current through the switch is IS if S is the switch, and the current through the diode is ID. If we give pulse to the switch, T off is first there, so the switch is off. Then that condition, the inductor discharges and the capacitor charges. Diode current is same as the inductor current, so it also discharges during the off condition of the switch. As the switch is turned on, then the current through the switch increases and is same as the inductor current, so inductor current also increases. The diode current becomes 0 as no current flows through the diode, and the capacitor meets the load by discharging. This cycle continues, and this continuous conduction mode operation. And as you can see, during on condition, the current through the switch is same as the current through the inductor, and other times it is 0 when it is off. So now if you consider minimum ripple, it can be considered as a constant current whose mean value is same as that of the I input or IL during on condition. So now if P in equal to P naught and V in by 1 minus delta equal to V naught, then I naught by 1 minus delta is I in. So input current is I naught by 1 minus delta, and if we get the input current, then we can find the RMS value for this given waveform considering this as constant equal to I input, the mean value as I input. So I input square, that is square then mean then root to find the RMS value. So square into the area under the curve, so you take the area into T on divided by mean divided by the whole time period, that is T, and root. So you get I input into root over D, that is D is the duty ratio. Now the IL RMS or the I switch RMS is same as I input into root D. So coming to the solution, I switch RMS equal to I input into root D. Now how to find out duty ratio? Duty ratio I told you, V in by 1 minus delta equal to V out. So V out is 400, V in is 360 divided by 1 minus delta, so delta is 0.1. Now I naught equal to, it is given as 4 kilowatt power, so load is 4 kilowatt and voltage is 400, so 4000 by 400 equal to 10 amperes. So I input equal to I naught divided by 1 minus delta, which is equal to 10 by 1 minus 0.1 equal to 10 by 0.9, which is coming out to be 11.1 amperes. Now we know I input is 11.1 amperes. So just we need to replace the values here. The I switch RMS, which is to be found out, is coming out as I in is 11.1 into root 0.1, which is coming out as 3.5 amperes. So answer is 3.5 amperes.